The energy trapped by man-made global warming pollution is now equivalent to exploding 400,000 Hiroshima atomic bombs every day. That's a lot of heat. And my topic today is how design can solve the climate crisis. The problem with all that heat is it's having a huge effect on the things that keep life in balance. For example, Glacier National Park has gone from 150 glaciers to only 25. So like Prince, I think soon we'll be calling this place the park formerly known as Glacier. Here's a graph of CO2 and temperature going back, paralleling each other for 800,000 years. In 2013, we saw an unprecedented 400 parts per million of CO2 in the atmosphere. And business as usual leads us to 600 parts per million by the year 2050. So what's causing all this carbon? Architects. The big elephant is buildings. Building energy use is about equal to industry and transportation combined. And buildings account for almost half of the CO2 produced in the US. Luckily, nature has provided us with a solution. The bars on the right show the energy needs of residential and commercial buildings, and these are not even energy efficient buildings. The bars for each city show the solar energy that's available on roofs and south facades. So you can see that even in cloudy Seattle, there's more than enough resource. So the climate crisis is really a design problem, and it can be solved by design, by gradually reducing the fossil fuel used by buildings to reach a carbon neutral goal by 2030. And it turns out already more than half the architects in the country have made this commitment and pledged to make their buildings carbon neutral. So if the building sector follows this path to the 2030 targets, it will reduce its CO2 contributions to 1990 levels and even lower. This is solving the climate crisis by design with carbon neutral buildings that embody a high performance design intelligence. So what we really need now is education to close the huge knowledge gap. So my work is about creating new knowledge structures for net zero energy design. This is a matrix from my latest book, Sun, Wind, and Light, which organizes design knowledge here by scale and energy topic. And each of the items in the matrix is a design strategy, and each design strategy is organized like this, each one in a 2 to 10 page spread. So this is a diagram of the structure of every energy design strategy. Now each strategy includes a category, an explanation, an elegant example that we in a field call precedents, and a series of tools and symbolic icons, starting with the urban scale here and moving down to the scale of buildings and rooms and down through the scales of building parts and materials. 115 design strategies are combined into a design strategy map. 9 levels of nested complexity in an ecology of knowledge. Now these strategy maps are help to create strategy bundles. And the bundles are families of related strategies that are organized to solve a recurring design problem. This bundle helps someone to design a cooling neighborhood and has a hot humid climate and a hot arid climate variation. We also developed something called the Bundle Up game to teach designers about the Sun, Wind, and Light knowledge base. It's also used as a tool for collaborative team design. So first we tested it with teaching peers and then in several design studio and lecture courses. The students use this knowledge to help them to design high-performance, low-energy buildings. The students also strive to make the buildings elegant and to make them rich places of human experience. Now these designs are from one of my studios, and they're actually the work of students in the first year of the design school. So I really wish I could have done work like this in my first design studio. The next student project here is from a more advanced fifth-year studio that I call High Thought, Low Tech International Design Studio. We collaborated with Professor Sharad Sheth from Gujarat University, and where his students and my students both designed sustainable low-income projects for Gujarat, India, and for Tennessee. Now these UT students used Sun, Wind, and Light design strategies to design passively cooled buildings with no air conditioning in a hot climate. And so by using local self-build construction and rainwater harvesting techniques, the students are learning how to solve the climate crisis by design. Now, this studio was half problem definition and half design based on the problems that the students themselves defined. They decided to design carbon-neutral brew pubs and beer gardens in 7 different climates. So this one is in Marfa, Texas, which is warm and dry, and you can see the diagram on the lower right. This one's in hot, arid Phoenix. Each of the projects in the studio was designed by 5th-year students in pairs of designers. Each one is heated by the sun, it's cooled by the wind and the earth, it's lighted by the sky, and each of the student projects actually produces more energy than it consumes. So for me, it's a great privilege to be creating new knowledge with these inquiring minds. And their questions are actually, in the studio, what drives my own research process. So these are graduates and undergraduate students that worked on the Sun, Wind, and Light project over 4 years. And among other things, they learned to draw in hand by ink, old school, and you can see some of their drawings here on the screen. We also take these design logics up to the urban scale because buildings and cities are an integral pattern. So this is a cooling plan done in my lab for downtown Chattanooga using climatic design strategies to create a breezier, greener, cooler vision of sustainable urbanism for a warm, humid city. And then this is that same plan in Chattanooga, but this time looking at sunlight for every building. So the built environment is a big polluter, yet it's also the solution to climate change. New knowledge structures can close the knowledge gap. And that's part of what we're up to at the College of Architecture and Design, which has committed itself to this idea of sustainable urbanism. Thanks.